Hey everybody, it's Monday, April 27th. Hope everybody's doing good. Today I'm going to show you some information out of Chapter 5, Logarithms. You have to know how to go from logarithmic form to exponential form, and the other way from exponential form to logarithmic form. So, if it's in logarithmic form, you'll know it because it'll have the word log in it. And if they ask you to write an equation that's in logarithmic form into exponential form, here is how you do that and what you need to know. The little subscripted guy down here is your base. Logs are exponents, so this guy right here is your exponent. And then this guy is your solution. Alright? That guy is your solution. So, if I say log subscript A, B equals C, and I say write that in exponential form, it's going to be A to the C equals B. So that's your formula, so to speak. So I always say logs are exponents. Logs are exponents. Logs are exponents. Okay? So that's some general information you need to know. The normal base for a logarithm is 10. The normal base for a natural logarithm, abbreviated ln, is e, your exponential function. E is your exponential function. It's not a variable, it's your exponential function. Alright? So then, and if you forget that on your calculator, if you look on your calculator left-hand column, just to the left of the 7 is the log button on your calculator. Well, in yellow, right above that, right above the log button, in yellow, says 10 to the x. So that will remind you that the normal base, if you forget, for a logarithm is base 10. Right underneath that, to the left of the 4, is your natural log button. And if you forget that the exponential function is the normal base for the natural log, well, if you look at your natural log button on your calculator, in yellow, right above that, is your e to the x, the exponential function. So that's a way that you can remember what the normal bases are for the log and the natural log is. So logarithms are abbreviated log. Natural logs are abbreviated ln. Some more things that you will need to know how to do. Say I give you log subscript 3, 81 equals 4, and I say write that equation that's in logarithmic form into exponential form. Well, in exponential form, this little subscripted number down here is going to be your base. Logs are exponents. Logs are exponents, so 4 is the exponent, and it's going to equal your solution, which is 81, and 3 to the 4th is 81. If I give you log subscript 2, 32 equals 5, and I say, hey, write that logarithmic equation into exponential form, 2 is going to be your base, 5 is the exponent, logs are exponents, equals 32. So you have to know how to take equations that are written in logarithmic form and write it in exponential form and vice versa. So I'm going to give you a couple equations in exponential form. You have to know how to write it in logarithmic form. So we have 2 to the 6th power equals 64. That's exponential form. I say, hey, write that in logarithmic form. You're going to write log. What's going to be your base? This guy right here. That's your solution. Equals 6. Logs are exponents. So this little subscripted guy is your base. 2 is the base. Logs are exponents. So your exponent's going to be what your log equals because logs are exponents. I know I keep saying that, but that's what I'm trying to ingrain into your mind. This is your solution. So log subscript 2, 64 equals 6 is how, this is exponential form. This is logarithmic form. If I give you 4 cubed equals 64, and I say write it in log form, okay? Log 4, 64 equals 3. 4 is the base, logs are exponents, 3 is the exponent. This is your solution. So this is exponential form, and this is logarithmic form, and you have to know how to go both directions, from exponential form to logarithmic form and logarithmic form to exponential form. The other thing I'm going to show you today, in the last topic, if I say, hey, what's the log of 48, all right, and there's no subscripted guy down here. If you don't see a subscripted guy down here, that means the log has its normal base, which is 10. All right, so if I just want you to evaluate the log of 48, all right, you're going to grab your calculator. Like I said, your logarithm button is just to the left of the 7. Log 48, close parentheses, and it is approximately 1.68. If you get a decimal and it doesn't say what to round to, always round to the nearest hundredths for me. All right, so what that means, if that's actually the answer, that means 10 to the 1.68 power should be really close to 48. And if you check that out, 10 raised to the 1.68 power is really close to 48. How come it's not exactly 48? Because we did an approximation on our answer right there. So, but it is really, really close to 48. So if you don't see a subscripted guy down there and I ask you to evaluate a log of 48, you just type it in on your calculator. If I want you to evaluate this log subscript 589, you can't just type it in your calculator because this guy doesn't have its normal base. So you got to use the change of base formula. And the change of base formula to figure out this answer, you're going to have to go the log of 89 divided by the log of your subscripted guy. What you need to remember when you have to utilize the change of base formula, you always divide by the log of your subscripted guy. So you take the log of whatever's out here and you divide it by the log of your subscripted guy to get this answer. So if I were to do that, log of 89 divided by the log of 5, it is approximately 2.79. All right? And if you doubt your answer, okay, logs are exponents. All right? So to see if that's correct, 5 is the base. 5 to the 2.79 power should be really close to 89 if this answer is correct. And if you take 5 and raise it to the 2.79 power, it is really close to 89. Once again, how come it's not exactly 89? Because this is an approximated answer. All right, we rounded to the nearest hundredths. So one more problem like that, and then I'll be done with this lesson for today. So we have log subscript 8, 412. And I want you to evaluate that and tell me what the answer is. Well, once again, you can't just type log of 412 equals because we don't have its normal base. If there was nothing written down there, then you could just type it in, log of 412 equals, and your calculator will give you your answer. But, if there's nothing written down there, you can assume that it has a normal base of 10. But it doesn't. this problem, I had an 8 down there. So we don't have a normal base, so we got to use a change of base formula. So how do we get the answer to this with our calculator? We're going to take the log of 412 and divide it by, if I could write a little better, divide it by the log of 8. Like I said, it's the log of whatever's out here divided by the log of your subscripted guy. You always divide by the log of your subscripted number. So if I do that, the log of 412, close parentheses, divided by the log of 8, it is approximately 2.90. All right? And if I want to see if that answer makes sense, 8 to the 2.90 should be really close to 412. 8 raised to the 2.9 is close to 412. Did I type that in right? Log of 412 divided by the log of 8. Yeah. All right. And it is close to 412. Why is it not exactly 412? Because once again, we rounded our answer. So that's what I got for you today on logarithms and exponential functions, and we'll continue tomorrow.